the question number two. Here we are going to see the Bayes theorem with a small example. So Bayes theorem help us update a probability when new information is given. The formula Bayes theorem is given by this: probability of A by B is equals to probability of B upon A, and into probability of A by B into probability of A upon probability of B. So let's walk through the simple algorithm of this Bayes theorem. So first of all, we start by defining the prior probability. For example, the probability that a person has a disease, and then step two, define the prior probability likelihood, the probability of a positive test if a person has disease and if they don't. And the step three, compute the total probability of the getting a positive test. Moving on to the step 4, we in this we substitute everything into Bayes formula to get the updated probability. So now let's apply it quickly. Suppose a disease affects 2% of people. A test is 90% accurate and the false positive rate is 5%. So when we plug values into Bayes formula, we find out that even after a positive test, the chances of actually having the disease is only about 26.8%. So this is why Bayes theorem is extremely important in medical testing. Here is the one more example. It is the same example we did right now. 0.67, this is 7% of the positive positive test, and after applying the Bayes theorem, we got 26.86% of actual diseases. Now moving on to the question number two. Here we are going to compare binomial, normal, and Poisson distribution. So now let's compare these three measures probability distributions. The first we are going to take binomial distribution. So it is used when there are no fixed numbers of trials, each with success or failure. So for example, include a coin tossed, and equally we check the uh, not a biased coin, a fair coin is tossed. And another example is quality checks or true false exams. So it is a discrete distribution. Okay. Now moving on to the normal distribution, this is the famous bell curve. This is the famous bell curve. It's continuous and used for naturally occurring measurements like height, weight, and IQ. Or we can also find errors from this. So it is always symmetric. Now moving on to the Poisson distribution, this model are rare events happening in a fixed intervals. So like numbers of calls per minute in a call center is an example of Poisson distribution, and accidents on the roads are also a rare event, so we can also count them in Poisson distribution. Or a system failure in any firm or any uh, laboratory, it will also be counted as a Poisson distribution. So it's a discrete and usual right skewed unless the average rate is large. So this was all about the question number two. We have seen the Bayes theorem and we have compared the distribution curve, the probability. So basically Bayes theorem helps update probabilities when new evidences appear, and the binomial and normal and Poisson distribution each apply to a different type of data scenarios. So that's it. This was the question number two, and the next video we are going to cover the question number three. So stay tuned.